Okay, so we want to present the results of one of the Google Summer of Code projects. And this project was about improving code completion in Pharo. This was done with Myroslava as the student of the Google Summer of Code project, and myself as the mentor. And so that means that my role in this presentation is to explain the problems, and Myroslava will explain what we then did to solve the problem.
Okay, so to begin with, what is code completion? Basically, to put it simply, code completion is a context-aware tool that helps developers complete the code that they are typing. So, for example, it might be something like you have one, and then you have the type, and then, or you can have a global name variable, etc., etc. So, in our case, it does it from the second symbol. And that was pretty much the case in the old completion as well. That is still available in Pharo, but not by default. And so you might ask, so this tool existed and it worked. So why was the need to improve it for us?
So that's where I come in again. So the question was, oops, I need to change it a bit. I take it out. So the question was, code completion, we need to improve it. What do we do? As it was a Google Summer of Code project, the idea was to find a way of doing it in a way that we could actually come to incrementally to some improvements that we can actually add to the image instead of, for example, starting with a completely new implementation. So what we then quickly saw is that the old system, the current completion system that you have in Pharo 7, that it has a number of problems that we could actually solve. These problems can be actually nicely parceled in kind of three directions. So the first one was the parser that is used to make sense out of the text that you see, so that the system can actually know what to present. Then on the level of the model that it creates to be able to answer the question of what is a good completion. And finally, the question on how do we sort the results in a way that they're good for the user. And what we will do now is to explain these three problems one by one in a bit deeper way, and then explain a bit of what our solution was. So the first problem is the parser. So if you look at Pharo 7, then into the package that does the completion, then you quickly see that there is actually a parser called SHSTAD parser or something like that. And this parser actually came from the syntax highlighter. So it used to be in the syntax highlighter package, and the person implementing code completion reused that. When we then changed the syntax highlighting, the parser was moved in the completion package, and now it's the sole user of that. And so the first problem was to solve what do we do with this parser implementation.
Okay, so our solution was to use the RB Parser that is used for syntax highlighting in Pharo. With the help of it, we are able to analyze the text that we are typing and parse it at every keystroke. And we can even parse the syntax error. So, for example, we have a parse error note that explicitly takes care of the error encode. So in this case, our main parsing method was parseSource, where we we basically have the parse faulty expression method. And with this, we are able to analyze the expression that we are typing, and then we get our AST because we know the exact node that this is. And with the help of the type-in visitor that we created, we can assign the type to it. And then at a later point, we use it to specify the completion for each of the nodes. So the type-in visitor itself, it comes from, so the AST in general has not enough information. So it is pretty useful in most cases, but the type-in information is only available for some of the things, for example, like super or self or global variables or direct assignment attempts. So there are cases when we lose it. If we have, for example, a double message sent, then we are already unable to specify the type. And the type check in general, so when we assign the type to nodes, we can later just check it property at type, and we get what we want. And based on that, we have a completion producer class where we determine different completions for each of the nodes. Okay.
So then we come to the next problem. If you look at the old code completion, it uses a very elaborate model. So that's a model class hierarchy with, I think, 4 subclasses. Depending on what kind of thing you have, if type information is available or not, with lots and lots of local state. And to us, it looked like that this is not really needed if we have the AST. So the next problem was, can we come up with a simplified model?
Yeah, so as I said about the type annotated AST, and the completion producer is our main class that does, so this is most of the work for our completion tool, because this is where the completion suggestions are determined. So in reality, it looks like this class. And then we have visit methods and for each of the nodes. So for example, for an array at the moment, we don't have anything, but for a message node, for example, we get the, so if we have the type, then we only suggest selectors based on type. And if we do not have the type available, then we give all the selectors. And so that is for all the nodes that are available to us. And yeah, and the way we find nodes to begin with, after we've parsed the source code, we go into the node for offset method. There used to be a best node for, which basically finds the best node for the code that we have. So we go into the node and check if it has children. If it does not, then this is the node that we need. And if it does, then we go to the children and check if they fit better. So for example, if we have in the editor, if we have a method, and then we determine that this is a method node. So for example, like, so this whole thing is a method node. And then we are able to determine that part of it is a sequence node, and we go into the sequence nodes, and then we are like, okay, so this is an argument, for example, or this is a message sent. And we go into that and complete then based on this determination. Yes, and as for the model results, basically with the help of this AST idea, we were able to simplify the code a lot. And we do not have official benchmarks yet, but there has been a lot of feedback from people who use large images that it is a bit faster than the old one. So yeah, so the speed is not a problem for this one. Yeah.
So the third problem. If you look in Pharo 7, then one reason why the models are so complex is that there is a special model called e-completion, which is a fancy sorting algorithm for the results. And so the implementation is actually quite complex because it hacks itself into the model. So we were thinking that it should not be that complex to implement sorting strategies for the results. because there are lots and lots of ideas that people have to sort. So e-completion, the basic idea behind is that all the methods that you compile, all the selectors in those should be prioritized. But that's just one idea. There are other ideas. And we wanted to make it easy to plug in a sorter into the system.
Yeah, so in general, for the alt completion, as Marcus mentioned, so O completion was basically pretty much a separate tool. But the actual main completion, that was the default up until Pharo 7, it was just sorted alphabetically, but there was no specific place where it was, like no specific implementations for it. It was somewhere in the code. It was just like, sort this alphabetically. What we decided would be nice is to have a separate sorter plugin that would be easily modifiable if we want to add more strategies. So we basically have this one class with subclasses, so there's code on the class side. So we have different subclasses, and this is essentially the stuff that we use for sorting. And we were able to plug it into settings. So now if we go to settings and we choose what we want to sort by, we can just easily do it. So for example, if we have one, this is alphabetical right now, and then if we want to do, so reverse alphabetical is just for testing right now, but it's just to see that it works. Now we have reversed the order. So the idea is that we want to work on more sophisticated sorting strategies. So one example is that we want to use the n-gram model and basically determine the most likely tokens in the context that we are typing based on just code probabilities. And then another idea is to bring back O completion, but this time as just one of the sorting strategies inside our tool, as opposed to something completely separate. Yeah. And so for the refactoring results that we calculated in our project, we were able to reduce the number of classes, methods, and lines of code at least in half, was our implementation in comparison to the old one. Yeah, for the more improvements.
So in addition, we managed to improve some things. So the only real new capability that it has is that we added completion for symbols, which didn't exist in the old system, which is quite nice. And it actually completes all possible symbols, while completing selectors, of course, only completes possible selectors. Another thing that we did is we found some problems in the AST implementation. So, for example, the AST was actually not used for our purpose before. So that means that there were some either newly introduced bugs or things that never worked. For example, an incorrect stop when you asked the sequence node, it didn't really know where the start and stop was. An incorrect start in a parse error node, because nobody ever used parse error for this kind of stuff. And then some bugs for recognizing parse errors in a correct way and setting the parse error node correctly. And we will see, I'm sure there are more of these tiny bugs in the system that we can find. But we did actually set this new code completion as the default in Pharo like 3 weeks ago, or even something like that. And so we did it in steps, because first we introduced only the parser, reusing the old model, then we introduced the new model. And if you find bugs, please report them, because we would really like to clean up and remove the old code completion as soon as possible, because this will remove something like 5,000 lines of code. And that will be, and then we will even be able to refactor more, because we now need to follow the API that is shared between the old and the new. And as soon as we clean up, we can actually change the client to in some way and make it even smaller. Future work. yeah, as Myroslava already explained, we want to have some machine learning-based sorting strategies to look at them. We do not yet have implemented, so when you are in a piece of code that is highlighted, that is colored red because it's a syntax error, then right now you get no code completion. But of course, it's possible to add that there. There are multiple ways that we know that should work. It only needs to be implemented. So for example, a fallback to just find the words under the cursor and propose all possible selectors and variable names has to be there. But we can even do better than that. And then something that was not the scope of this project is to go beyond selector completion. So our goal was to do the same than the old one. But if you, for example, think about if true completion, you might actually want to complete already the start of the block and position the cursor, or better handling of completion of of multi-part selectors, for example, would be one of those things that would be desirable. Thanks a lot, and questions.